OK, so quickly, I'm Clément. I'm a developer at a company called Fretlink. I like to shitpost on Twitter. If you have something to say or questions during the talk, don't hesitate to put them on Twitter, and we can discuss there afterwards. And I have a blog that I don't update nearly enough. But anyway. Quickly, work for my employer. Fretlink is a company that connects shipper to carriers, and we help people send pallets through trucks in Europe. So it's really interesting. We can talk about it later if you want. It's really interesting in terms of technology we use to optimize cargoes, pool stuff, and everything. So today I want to talk about config files, and it's a solved problem. We have YAML files, so everything is great, and we don't have to do anything more. At least that's what most of the industry thinks, judging by the number of projects that use YAML files to be configured. Sadly, authoring YAML files often end up like this. You have files that span like maybe 1,000 lines with 50 levels of indentation, and a single typo can bring your production down. And there was a huge down yesterday on the Google platform, and all signs point to a single typo in a YAML file. So it's not a theoretical problem. It's really practical. So YAML has issues. I could spend hours shitting on YAML, but that's not what I'm here for today. Lately, there has been another config file format called toml, which fixes a lot of issues of YAML, especially ambiguity. Like if you put a colon in a YAML integer, if the numbers on the right side of the colon are below 60, it will be interpreted as a time. So it's really funny when you configure Docker with port A, port B. But anyway, toml solves a lot of problems, but that's not the problem I'm really interested in today. These are mainly syntactical problems, not bigger, more interesting problems. The issue is that configuration it's getting more and more complicated and repetitive, and especially now with software-defined network, software-defined everything. With infrastructure as code, no. YAML files can span thousands of lines. If you configure Kubernetes or Ansible, it's huge, really huge YAML files, and it's really hard to read them, to author them without making any mistake and everything. So configuration has become really, really complex and big, but configuration languages are designed to be simple. You don't want a language too complex when you're writing configuration. It should be boring. Or sadly, YAML is not simple at all. If you read the YAML spec, you will always find some new food gun to bring your production down. And that's the tension. On one hand, we have configuration that's gotten bigger and bigger thanks to infrastructure as code. And on the other hand, we have languages that are, by design, really simple and dumb and redundant. So a new trend that's old but that gains traction these days is configuration as code. Instead of inventing a new configuration language, just use an actual language, a regular language that everybody knows. For instance, something that everybody likes to configure Webpack. It's a fun activity. Everybody likes it and find it simple. So a simple Webpack config, it's just JavaScript. You can use variables and everything. So no new language to learn. So it's just JavaScript. You don't have anything new to learn. It's the same language as the rest of your stack, and it just works. You have simple abstraction. You are able to use variables, functions, stuff like that. So no new thing to, no repetition. You can use variables like in regular code. And you can use imports. It's really useful because it allows you to split your configuration file into several pieces in a semantic way. It's not like concatenating config files, which is not really interesting. You can add structures when splitting your config files. Unfortunately, it's not all peach and gravy. It's JavaScript. And JavaScript is cool, but if your config files turn into, let's say, Angular 1.2, not so good anymore. It's nice as long as it stays simple. But if you take the full power of JavaScript, then it gets a bit more messy. And another issue with that is that you have to run npm install to get the configuration. So in most Webpack config files, you will rely on plugins and plugins that are installed through npm. So to get the configuration of your project, you have to run npm install. It's not just a JSON file that you can read anymore. It requires more complex steps beforehand to be actually useful. And it boils down to side effects. It's arbitrary JavaScript. So when you read the configuration, you're executing JavaScript. So anything can happen. So are you able to, do you know when the Webpack config is read? Because when it is read, then some side effects may happen. Are you able to cache it? I don't know. Does it rely on external programs that it calls? I don't know. Can I safely call it twice? Will it modify other config files? I don't know. Will it drop the production database? I don't know. It's JavaScript. So you can't cache any config files when you have a full language, because it can perform anything. And a big issue, you can't automatically audit your config files, because auditing your config files means running code. And running code, arbitrary code in a trusted environment, it's a pain in the ass. So using a full language to write config files, it prevents you from doing really interesting things with config files that are really trivial to do in JSON or XML. You read them and you can do stuff. At my previous company, we tried to inspect dependencies to know if people were using vulnerable dependencies. And for JavaScript and Java, it was easy. But when we tried to do that with Scala, which uses Scala as a configuration language, then the pipeline was prohibitively costly to build, because we had to run arbitrary Scala in our pipeline, Scala written by other people. In the end, it's just a black box. It says, it promises that it will provide some kind of configuration and maybe do something else, anything else. And that's the issue, because when we read config, when we read a JSON file, we don't expect anything. We just expect having a value with a tree structure, and that's all. Reading JSON does not perform arbitrary side effects. And that's a feature, because it's configuration. And the configuration is not code, because it's a separate life cycle. And if you follow the 12-factor application guidelines to build your applications, you will see that code comes before configuration, and configuration has to happen in a separate step, because you want to deploy the same code in different environments with different configuration. Meddling configuration and code in the same language in the same phase, it breaks this really important property provided when you follow 12-factor guidelines. So let's try to think about what we want from a configuration file. First, we want a syntax that is clear. YAML is a good counterexample for that, because the YAML syntax is notoriously ambiguous, and we don't want that. A config file, you need to read it and to understand it really in a simple way. You don't want to be too complex. And of course, syntax is good, but we want clear semantics, because config is just about providing a structural value that the application can read afterwards. You want just that, and that's really important. Another really important thing is to be able to split your config into several files and not let the application that reads config files do that for you. The config file should be able to be split in the way you want, not a way predefined by the application. Because if it's simple config, a single file will be OK. If it's big config, then you want to have the choice to split it, but you don't want to be forced. Having 10 config files with one line in each, it's not a good thing as well. For instance, the Apache configuration on Debian and Ubuntu, it forces on you the huge number of config files, and it's really not a good thing to. It's not enjoyable. And configuring Apache is already not enjoyable, especially not on Debian. And we still want some abstraction, because for simple config, then you write down everything, that's OK. But when config gets big and repetitive, then you want to be able to factor out the repetitive part, because it allows you to avoid typos, to clearly see the intent as well. You don't abstract as much as in a regular language, but you want to be able to have variables, maybe some functions to build some repetitive blocks, stuff like that. But, and that's a big one, you don't want to be Turing-complete. If you take a Turing-complete language for configuration, then you can more or less make its interpreter do what you want. Most of the security issues in the VLC video player, it comes from video formats that are too complex to parse, and the parser in turn gets really complex, and then you can make it do what you want. And config files, it should be a no-brainer. You read the config file, you get the config value, and that's all. You don't have to audit the config itself to make sure it won't break your computer. And of course, a pet peeve of mine, you don't want side effects. The semantics of config files are clear. They're just there to provide you with a value, and that's all. Having side effects is a definite no-no for config files, because you don't know what would happen, and you're not able to cache anything anymore. You're not able to inspect anything anymore, and it's basically you're fucked. That being said, there are some side effects that are OK. For instance, reading an environment variable from a config file. It's technically a side effect, but yeah, it's OK. It makes sense. So with that in mind, let's look at a language that was designed with exactly these guidelines. First, syntax. Of course, you have comments, which is the #1 issue with JSON as a config language, is the lack of comments. You have objects, you have strings, numerals. You have multi-line strings, which is a nice thing to have. Okay, so more or less what you would have in JSON: objects, lists, and some scalars. You can have booleans as well, stuff like that. Please note that the lists have to be homogeneous. Each element of the list has to be the same. We can work around it, but in a clean way. So I'll see that later. And in terms of semantics, yeah, it's that. A good thing to know is that every single literal in Dhall is unambiguous. We know what is its type, as compared to YAML, where the contents of the literal will determine its type. For instance, you can omit quotes on most string values, but if your string value has a certain form, it may be interpreted as a number. In Dhall, you don't have this choice. If it's a string, it has quotes. If it's just digits, then it's a natural number, and that's all. You can do imports by just referencing another file. So you can split as you want. Nothing fancy here. And you have abstraction. For instance, I want to provide a configuration bit, which is a record with field home, a private key, and a public key. Instead of repeating the name of the user, I can use a variable and string interpolation to make sure that it will be the same username everywhere. Okay, simple, just a variable. And we can take this a step further. We can make it a function. So instead of declaring the variable myself, I can declare a function and saying, I will take a value of type text and provide you with the config. So in your actual config files, instead of having repetitive records, you will just have make user bill. And if you have several users, then you can be confident that they will have the same structure. So if you have good sight, you will have noted the colon text. And yes, Dhall is a language with types, and which types are good. So what do we have? We have naturals. Interesting choice. By default, if you put digits, it's natural. It means a number greater or equal to 0. So you can have negative numbers if you don't put explicitly a sign. If you want to put a sign, you can. And then it's a regular integer. You have double, you have text value, you have bool, everything. That's scalar, so simple values. You can have composite values. For instance, you can say this variable may have a value or not. And it's an interesting thing to say. And you can say it in the types, like grown-ups do. So the value, it will be either nothing or some value. And you will have to take it into account later on. If you have a list, you can have it. All values will have the same type. And you can have records with key value semantics. You can compose records both at the type level and at the value level. So let's say I have a type called user, which is a record with a name, a text value. And I can create a new type, which is everything that user has, plus some new field called level. And then I can define a value of type admin. And the compiler will make sure that it has all the needed fields. So it's really flexible. You can mix and match records this way. You don't have to declare every combination beforehand. You can combine it on the go. And one really, really neat trick is something called union types. So often in configuration, you will have a value that has either one shape or another. And you can describe that in Dhall. Let's say I want to talk to a service. So it exposes a socket, either as a file on the file system, if you want to address it locally, or more usually, as a pair of IP address and a port. And this is not the same structure. You could represent it as two strings, but it's not really structured. This way, I can say a host is an address and a port, and a socket is either a local file, and in that case, I give a path, or a remote host, and in that case, I give an IP address and a port. And then I can manipulate values that are either one of those. And if I have a list, I can have a list of sockets which combines both of them. So I can get back heterogeneous lists, but in a controlled way. Not everything has to have the same shape exactly, but I have to say which shapes are authorized, which is a good thing. And most interesting feature, it's not Turing-complete. So when you have a Dhall program that type checks, it's guaranteed to execute in a finite time and to not crash. So, big caveat on finite. 5 billion years is finite, but it won't run into an infinite loop. And all the interesting features of Dhall are not bolted on the language. It comes from the type system. So the semantics of the language, its core, it's designed to be a language that provides a limited amount of abstraction, doesn't crash, and evaluates in a finite time. And you can't do anything else because the type system doesn't let you express anything else. And when I say state-of-the-art type system, it's based on calculus of construction, like high-level, type-level stuff, used in Coq by people from INRIA. So it's a really, really well-designed language. It's not something drawn on the back of the envelope one day because the author was bored. It is extremely well-designed. And of course, it has no side effects because its semantics are clear. The only thing it does is produce a config value. So side effects don't have any place in that model. Not all side effects. You can read environment variables. So you can get a structure config value by reading env variables. So just for that, it's already an interesting tool. Instead of reading 10 of variables, you can put them in a neatly structured value and work on this value instead of just a list of strings. And you can either read them as text, but you also can read them as proper Dhall values. So if you have a port environment variable, then it will be read as a natural number. You can import stuff over HTTP. So if you want to reuse code, you can import them over HTTP. It's extremely restricted because running random HTTP calls is not really secure. So you have guarantees that it will not exfiltrate information. For instance, anything read from end variables can be used in HTTP requests, stuff like that. And you have a tool to freeze all the imports. So when you do that, it will cache the HTTP import and put a hash in the source file. So the next time you evaluate your config file, it won't even run the HTTP call. It will just take the value in the cache, and that's all. So you can use HTTP for code reuse, but it won't actually make proper HTTP calls in production, if that scares you, and it should. So the semantics are really clear because they're separated. You start with your Dhall file. The first step is to resolve all the imports and to do all the side effects. So the output of Dhall resolve is another Dhall file or another Dhall value with no side effect at all. And then resolve will evaluate it and provide you with a value that you can use. So if you start with that, so I have a list of naturals, and I want to map the even function on them. So I want to know if all these numbers are even. So when I evaluate it with Dhall, the result it gives me is this. And that's the value that your programs can use. So quick word on editor support. Know that editor wars are over and everyone uses VS Code. You have good support in VS Code, of course, syntax highlighting. But there is also LSP server. So it can provide you with type annotations, compiler errors, inline, stuff like that. And since it's LSP, it can be reused in any other editor that supports LSP, which is a good thing. And a super useful one is live preview. On the left, you have your Dhall config files. On the right, you have the JSON equivalent in real time. So when you're working on it, you can visually check that it generates a proper JSON file. So writing config files is good, but if nobody reads it, then it's kind of useless. There are two main ways to use Dhall. The first one is from your application code itself. So for instance, from Haskell, which is a nice language. Let's say my config is a simple object with just the port number as a natural. To read the config, I put in the config file path, and I say I want a config value. So it will interpret the Dhall file, resolve it to a neat value, and put it back to the Haskell world, and then I will have my my config files. I use it extensively to read environment variables in structural objects. So in a Dhall file, I'll declare objects with environment variable imports. So instead of a flat list of env variables, I get nested objects with strings, with ints, all I want. And then I get the same structure back in Haskell. And I don't have to do all this by myself. Of course, you can do it in Haskell, which is a reference implementation. It's a reference implementation, emphasis on reference, because there is a proper a standard for the language. So the language, everything is declared in a standard that is not tied to the Haskell implementation. That's important to know. You can use it from Nix, from Ruby. You can use it from Java. You can use it in Go. It's not a full binding. It calls an executable and gets the config through JSON. So you lose a bit in terms of expressivity, but that's not a big deal. And in progress, we have Rust, Clojure, PostScript, and Python. The Rust implementation is really, really interesting because once we have a Rust implementation, we can have bindings in many languages. For instance, JavaScript, or even we could have it in JavaScript in the browser if you want, because Rust cross-compiles to many platforms and is easy to bind to scripting languages. So that's the most interesting implementation right now because it will unlock many other implementations in other languages. And I don't want to implement a type system in JavaScript. So that's one way. But sadly, YAML and JSON are not dead yet. Some stubborn developers keep on wanting YAML files and JSON files for configuration. And we can't force them to rewrite all their application in Haskell. I would love it, but I can't decently expect it. But fear not, since the semantics of Dhall are really clear, we can port any Dhall value, except functions, to a JSON or YAML file. So if I have a big Dhall file, I can turn it into a YAML file. For instance, I have this config file. So first part is a function. Based on a username and a list of groups, I generate an object with the name of the user and metadata containing groups and the user type. And then I declare my list of users. So the important part is at the bottom. I can read that and say I have 3 users, Bill, Joe, and Roy Eastman Kodak. And all that, it's turned automatically into that, with the added value that a type checker has checked that everything is OK. And the type checker is one of the most important things when you use Dhall, because if you have software with big config files, with rich configuration, then one person has to write down the types, and then you can import it over HTTP and check if your config files respect this type. So you can have automated checks, even for application with no automated config checks. So for instance, there is a project called Dhall Kubernetes, which provides all the type definition for Kubernetes YAML files, as well as helper functions. So for regular and boring code, you can have functions that build the config bits, and you don't have to write down everything by hand. So Dhall Kubernetes, I don't use Kubernetes myself, but I think it's one of the most compelling reasons to use Dhall right now. It's to avoid having heaps of YAML files for your Kubernetes clusters. And even if you don't have YAML or JSON config files, you can use Dhall to text to convert it to custom formats. So there is an example to create a NetHack config file. All you have to do is, on one hand, you have to write down your config, your structured configuration. And on the other hand, you have to write down a function that turns your configuration into text in the format expected by the application. So same, once the projection function is written, you can share it and you can reuse it and focus on writing down structured config and not string concatenation code. So we've been using Dhall at my company for a few months now, in both uses. So both to read config from an application we write ourselves, and to generate YAML file for Ansible configuration. So we've tried out both of the use cases. If you use Haskell, don't hesitate and use Dhall to read config files. It's a no-brainer. You won't regret it. Just to read environment variables, just for that, it's really good. For the rest, don't go overboard, because yeah, Dhall, it's really restricted, but even with its simple semantics, you can express a lot of things. And if you don't pay attention, you will build a mountain of abstraction and complexity inside your config files. And that's not a good thing, I promise you. If your config is split in 50 config files with imports everywhere, then nobody will want to read the config file. Of course, theoretically, you can just evaluate the config and read the output. But when you edit it, you need to get what goes on in it. And Having two complex files, it's not easy. And yeah, you want to abstract away everything because it looks like a full language, so you bring back all your intuition of the old language. Don't forget that this is configuration, and it has a different life cycle, and it's not the same metrics of code quality in config and in code. In config, you can have redundancy, and it's even desirable in many ways. And don't forget that in the end, it's the ops team that reads your config file. So, of course, you can encode the unit lemma in Dhall, and it's cool. And if you like category theory, it's super fun. But I'm not sure your ops team will enjoy it. And in the end, it's the same as in any other language where you can choose the level of abstraction. You have to decide it as a team with your developers and with your ops team, which is the abstraction level everyone feels most comfortable at, and try to go this and not overboard. And of course, over time you can refine it. You can go a bit more into abstraction or a bit less as you want, but it has to be a team decision, and people that are not full-time developers should definitely have their voice in it, because config files written by an overzealous developer, it will make some people sad. And you definitely don't want your ops team to say, config files are too complex, I don't read them, I let other people do. Because in the end, if your devs are doing the ops, then we need both. So, but it's a bit, it ends on a downer note, but we've used Dhall for a few months, and we're like super happy with it. So it's a good choice, but you have to be vigilant of that. And to finish, if you go on the Dhall website, there is an interactive console, so you can type out Dhall code, and it will pop up as YAML or JSON on the next tab, so you can play with it, see how it goes. It's super interesting. And as I said, there has been tremendous work put into designing Dhall, and the wiki is a treasure trove with information and with thoughts about what config files and config formats should look like. So even if you don't plan on using Dhall, reading the wiki is really, really interesting, because you will learn a lot of things on many languages, what trade-offs were made, and everything. And it's a great read and really thought out. So I recommend having a look at it if you want to understand more about configuration and constraints of configuration. And I think that's it. Thank you.